The 11th question is actually based on a property of conditional probability. It is called law of iterated expectations. Okay, I will not give you a mathematical proof or uh, derivation or something for this. I will give you an analogy, and that too one based on Valorant, because I mean this video game was quite popular and still is. I mean, I personally haven't played it that much, but I hope it helps to understand. Okay, so let's consider X to be the total number of kills in a match, and let's consider Y to be the map. Okay, and for this specific explanation, I will only consider three maps. So it can either be Abyss, Ascent, or Haven. Okay, cool. So these are the only maps. Forget the other maps for now. Um, so let's start with E of X given Y. Yeah. So E of X given Y in this case would be the average number of kills uh, in a match given the map, right? So say you take Y as Abyss, right? E of X given Y, which is E of X given Abyss, if you consider that to be 1, I mean if you consider that to be the case, is basically the average number of kills in all the matches that you've played in Abyss, right? So similarly, if you take Y as Ascent, if you take Y as Haven, that will give you the average number of kills that you get in Ascent, and the average number of kills that you get in Haven, right? And sorry. Yeah, let's give these numbers. Say in Abyss, your average number of kills is 25. In Ascent, say it is 20, and in Haven, say it is 15. So this is E of X given Y that I'm telling you, right? Now, if you consider, say, the amount of time that you spent on these maps, right? So, say you play at Abyss, I'll use a different uh, color for this. So, say you play Abyss 40% of the time, you play Ascent 30% of the time, and the rest 30, right? Yeah, 30 you play in Haven. Okay, since these are the only maps we're considering, these add up to 100, right? Whatever time you spend in Valorant, you have to spend it in these three maps as per the analogy that I've taken. Okay, I've only considered these three maps as I've shown here. I haven't considered the other maps. So these will obviously add up to 100, right? Now, if we look at what E of, or the expected value of x given y should give us, it will basically be this percentages that you spent multiplied by this, right? Because this is x given y, and these are the weights that you have to take. So what will it be? 0.4 times 25 plus 0.3 times 20 plus 0.3 times 15, right? So if you look at what E of x should be, that is the average number of kills for the whole game, that will also be this, right? You think about it, because again you have to spend your time on these three maps. So it will be 0.4 times something plus 0.3 times something plus 0.3 times something. And what will these something be? That will be the basically the average number of kills in that specific map, right? So pretty much that is what we are looking for when we calculate E of x, and that is the same for E of or the expectation of x given y. So that's what this property that I told you, or the law of iterated expectations at the end gives us. That is E of x equals E of x given y, and that is the answer. The answer is C.